I'm accepting. I'm kind of crazy about my pens. All right. We are all about zeros today. Zeros or roots. So, before we talk about, I guess, the fundamental theorem of algebra, which we're going to touch on today, there is a theorem which you guys probably are not going to appreciate very much because it's been changed by technology. But you got to remember way back when Miss Comrie was a kid and we didn't have graphing calculators, there was not a way to like look at a graph and tell where the x-intercepts were. So very, very long ago, we had this thing called the rational root theorem. And what the rational roots theorem tells us is it gives us a list of possible roots. And I'm just going to pause for a second because the word root means multiple things. What am I talking about? I'm talking about on a graph, x-intercepts. I think that's probably the most common way people think of them. Or another name for them is the zeros. Or even sometimes the solutions. I'll squeeze that in, solutions. Okay. So when I talk about root, talking about the x-intercepts of the graph. So there is a way from the equation of a polynomial, we can generate a list, and we're going to practice today doing that. And the list is going to help us figure out what the potential x-intercepts are. And then at least then it will help us narrow it down. So the list of possible roots are going to be of the form P over Q, and you don't know, you might be thinking, what does that mean? Okay, so they're going to be all fractions, or could be written as a fraction. Like for instance, 3, the number 3 could be written as a fraction, 3 over 1. Okay, so these would only give us rational potential zeros. What is P going to be? P is going to be all of the factors of the last term or constant. And Q are the factors of the leading coefficient. Okay. And so before we're going to talk about this fundamental theorem of algebra in a minute, because this is going to tell us how many zeros there are actually in the function. But this gives us our list from which to choose. And then I'll tell you what I had to do, and then you'll feel sorry for me, and then we'll use our technology. All right. Or maybe you won't feel sorry for me. So in example 1, and actually we're only doing part of example 1 today because this in itself is like enough practice where this process is all we're going to do today. Is we're going to find the list. We're going to then decide which ones from our list are actually zeros. So when I want my list of zeros, I like to organize it in this way. I write this P over Q. And what I'm going to do is I use this little chart to help me out. So just put the P on top, the Q on the bottom. And what I do then is this P on the top have to be factors of the constant. And the constant are this -4. And so what we're going to do in this top row and I'm going to have you with your neighbor talk about this. What are the factors of 4? Like what numbers multiply to be 4? Go ahead and talk about that. Awesome, awesome. Okay, first of all, we do have to write plus or minus because it's positive or negative for all factors, because it could be a positive times a negative times a positive. Even if it's positive, it could be positive, positive, or negative, negative. So I put a plus or minus. I heard 1 and 4. I heard 2 and 2, right? All right, so those are all the factors of the constant. Now I'm going to go to the bottom. These are going to be all the factors of the leading coefficient, but there's nothing written there. So what's really there? 1. This one's kind of an easy one. That's why I have us do the worksheet, because we're going to look at the worksheet and look at those later. The only factors of 1 are plus and minus 1. Okay, this is not my list yet. It just helps me make my list. So I have this list here, and I have to do all the combos with all of those numbers on top and all these numbers on the bottom, but there's only 1. So in my list then, I put a plus or minus out in front, and I would have 1 over 1, which is just 1. The second thing on my list would be plus or minus 4 over 1, which is just 4. And the last thing on my list is plus or minus 2 over 1, which is just 2. And you might think, well, why couldn't I just do the first term? Because sometimes, or sorry, the last term, sometimes in a minute, I'm going to show you we have things that there's a number in front so that the thing on the bottom isn't just a 1. And I'll show you how to do that. So what this means is the possible zeros of this are only plus or minus 1, 4, and 2. Okay, so what I had to do as a student then is, do you see this equation up here? I actually had to go back into the equation, and I had to plug all 6 of those things into my list, and I had to figure out if any would give me 0, okay? But we have technology, so I might make you confirm some things. So what we're going to do is we're going to compare our list with Desmus or a graph. So I'm going to see if you guys can just see from my graph which ones are. Okay, can you guys see that? Make an educated guess as to what you think the x-intercepts or zeros are. Each of these is a tick mark. Plus and minus 2. Okay, so hopefully you're seeing there. Yeah. All right. So that's going to be your process today. If I was actually then saying, what are the real zeros? I'll tell you why I have to say real zeros in a second. The real zeros of this one are just plus or minus 2. And you can look at the graph to get those. On Monday, I'm going to also show you on the one thing that is cool about the graphing calculator as compared to Desmus is there's a table function in your graphing calculators. And then instead of plugging in, you can actually plug them into the table. So I'm going to press in 2, and you can see it confirms that it is a 0, and -2, and it confirms that it's a 0. So I'll show you that on Monday, though. So that's a nice other way that you can confirm that they're zeros. All right, now to lay the groundwork then for next week, let's just finish up with the fundamental theorem of calculus. And we're going to revisit this next week. The fundamental theorem of algebra, sorry, I teach calculus as well. There's 2 of them. It says a polynomial of degree n has n complex zeros. And I'm going to add something to that. We're going to add something to that. Some may be repeated and some may be non-real. So the very last thing I'm going to tell you then is this picture of my graph. Well, first of all, what's the degree of this polynomial? 4. So what this is saying is it should have 4 zeros. But is that what the graph says? No, the graph says 2, right? What that means is there are 2 more, but they are imaginary. Do you remember when we did things with eyes in chapter 2? So what we're going to work on next week is, well, how do I find the imaginaries if I can't find them on the graph? Okay. But we're going to save that part for next week. Okay. Let's practice this process one more time with, I gave you this worksheet, which you're going to work on for class. Let's pick one where there has a little bit more potentials for our factors. Let's look at question number 4, please, on here. All right, so the process for these, so we're going to use, and you can use your notes if you want, this P over Q business. You can use a highlighter if you would like. And this one, I just want the possibilities. You don't have to find them. So this one is just the list. When we get down to this section, 9 and 10 and beyond, I actually ask you to find them. All right, so on question 4, we're going to write P over Q. I am going to make sure, because sometimes people flip them around. They, for some reason, want to do the leading coefficient first, but it's actually the last thing that goes on top. All right, we have to list all the factors of -8. Let's go. Just shout them out. Not all at once. 4 and 2. Somebody said it. I heard them. What else? 1 and 8. All right, now on the bottom, I'm going to list all the factors of 5. What are they? 1 and 5 only. Okay. Do not stop here. This is used as a tool to generate the list. So here is my potential list. I start with the 2. I go 2 over 1. What's 2 over 1? 2. I also have to do 2 over 5. 2/5, and I'm just going to leave it like that. All right, now I move to the 4. I have to do 4 over 1, which is 4, and 4 over 5, 4/5. I need to do 1 over 1, which is 1, and 1 over 5, which is 1/5. 8 over 1, and finally 8 over 5. And notice I just put a plus or minus in front with a parentheses. That way I don't have to keep writing plus or minus a bunch of times. In this top section, you do not have to go graph after that, okay? By the way, for graphing, you can use a graphing calculator or you can use Decimus. All right, so now let's do one where you actually have to find them. Would you flip on the back and would you look at question 14? Okay, the instructions on this is first we're going to state the possible zeros. We're going to state the possible zeros in the way we just did. Then we're going to find the rational zeros. We're going to confirm with a graph. So if you have your Chromebook handy and you want to get it out, you can. All right, so, or if you want to use one of my calculators, you can use one of my calculators. Let's first make the list. Well, on this one, they're both 3s, so that's pretty easy. What are the factors or things that go into 3? 1 plus or minus, and 3 plus or minus. Then I have plus or minus 1 and plus or minus 3 on the bottom. So my list of potential zeros, we have 1 over 1, plus or minus, 1 over 3, 3 over 1, and 3 over 3. But hold on a second. Isn't 3 over 3 just 1? So do I need to write it again? Please do not. You don't have to write it again. You're going to have that happen sometimes. Okay. What you're then going to do is either confirm on Decimus. I'm going to use my graphing calculator. I'll show Decimus after this. I would have to graph this. So I go ahead and graph this. Oh no. Okay. Now, this is interesting. They look like there are actually all 3 of them are on my list. What would be your guess for this one? That looks like -3 to me. That looks like -1, and that looks like 1/3. Now, you're going to, on Decimus, be able to click on them to tell that, obviously. The graphing calculator is a little harder, but this is where I told you I can't show you this. I just don't have enough time. We said -3. That is definitely a 0. You can use the table function. What did I say? -1? And then 1/3. Okay. So, but let's look at Decimus a minute. What you're going to do is pop this up on your graphing calculator on Decimus and just put the cursor on the zeros to confirm them. Okay. Okay, the other thing you could do is once you look at the picture, you could plug them in the function. Remember how you were doing that with the remainder theorem? Like use your calculator, plug them in for x, and confirm you get a 0. That's how I had to do it back in the